Yeah, so actually the part in the title where there are problems, I would pronounce it just WWM, German 18K, where WWM is the acronym for Who Wants to Be a Millionaire? I guess a pretty popular game show in many countries. And what we did in our work, so it's joint work with a former bachelor students of mine, Louis, Philipp from Stanford, and Christian, my former PhD supervisor. What we were interested in is whether, and I think the previous discussion was a nice lead up to my plot here. Despite LLMs not being like formally structured as knowledge bases, the question we posed ourselves was how much knowledge is actually in there. I guess we all know they are trained on the whole internet, but still there might be some information or some trivia that the models probably didn't store properly or didn't even quote unquote hear about during pre-training. So what we did, we crowdsourced roughly 18,000 questions and the multiple choice answer options from this popular German game show. I guess it's available also this game show also exists in, I think, France, US, I think, also Great Britain and some other countries. And we ask ourselves the questions if LLMs could actually win the million euros in this case, or if they could at least win at least 500 euros, because the question difficulty is increasing across the money levels. So without further ado, let's jump into the context again. This was a particular case that happened a couple of years ago, where you see the moderator is also quite puzzled. And I think it's not super well understandable to non-German speakers. But the question was about there are some types of dogs in the answer options. And the question was, okay, who does have which kind of dog? And the candidate in this case, unfortunately, because like Riesenschnauzer is apparently some dog race, but here it was like separated. And the idea was, or this answer was stating that many giants have like mustaches, right? The correct answer would have been C, because it's a separation of sheepdog. And in German, it will say that, okay, most of the shepherds have dogs. So yeah, this was a pretty easy question, I think around 100 or 200 euros from a level. And yeah, the candidate actually had a kind of blackout and struggled with this. So this happens also to humans. And we wanted to see how LLMs do. So a little bit of background. I guess I can make this also a little quicker because Gerard also provided a pretty nice explanation to large language models already. So what is actually a large language model? I think this definition is still quite fuzzy. I would argue everything that relies on some transformer architecture as its backbone is an LLM. Probably BERT pertains to the class of more traditional LLMs, which I would classify as LLMs that actually rely on some class distribution within a softmax layer as the output and thus need to be fine-tuned. So BERT, as Gerard already told us, relies on the transformer encoder architecture part as a backbone, is pre-trained on next sentence prediction and masked language modeling to artificial tasks from self-supervised learning, used for getting some nice initialization of the weights, and can then be fine-tuned. And I specifically chose this part of the BERT paper. For example, let's see here for SQuAD, which is the Stanford question answering data set, for question answering. But you need fine-tuning for this, right? So how did this work for multiple choice question answering? In this case, what happens to BERT? You add a linear layer with a softmax activation on top. You take all the answer options, concatenate it with the questions. And here the question is, was denn Schimmel in German, which means like, what are Schimmel, some kind of horse race. And then for answer options, you feed all these four sequences then separately to the BERT backbone. You obtain the raw logits and convert them with a softmax to like some kind of probability distribution. And obviously you take that one, so you choose that answer option, getting the highest softmax score. So in this case, if you consider this example, the sequence was in Schimmel, and the answer option white weiße Pferde in German, so white horses, which is actually the correct one, also receive the highest softmax score. So in this case, this is how it works in Hugging Face. The model would have chosen the correct answer option. What is nowadays always like implied with the umbrella term, LLMs are mostly generative LLMs, like ChatGPT is probably its most prominent representative. Here it works kind of differently. You can just, and this is like the web interface to ChatGPT, you can just paste the question into the chat field. For example, this question about the dogs from before, and then ChatGPT provides you with an answer, or Llama, or whatever model you can think of. And it not only provides you with an answer, like in BERT, it just gave you the softmax score for the most probable answer, but also probably it doesn't stop talking to you and also provides you with an explanation. So ChatGPT here chooses the correct option as opposed to the candidate before, and also provides an explanation. So one thing we have to do is post-process all this and like parse it to get actually only just like C, for example, as the right option. The main contribution that was intended to be given by this paper was the data set, because we actually we accessed this interactive environment where you could like train for this show to crawl all the questions and the answers, to provide some language-specific evaluation, specifically for German, to cover a wide range or wider range of phenomena, stuff like trivia knowledge, factual or common sense knowledge, logical reasoning, syntactic abilities, so a wider range of different things. And also coming with the nice information of different difficulty levels. So this is actually how the producer of this game show sorted the questions. So 50 euros with being the easiest one, and 1 million euros being like the perceived toughest type of question, which is kind of one advantage over many other QA data sets, because they just have the question and the answers, but no inherent sense of difficulty. Data preparation, this is how the, on the very left, you see how the raw unclean data looked like. So we had a slight imbalance towards the easier questions. So overall, this is about 18,000 question answer pairs. Somewhat more questions of the 50, 100, and 200 euro cases. After removing duplicates, there was some, the number of questions reduced a little. And one thing that became apparent, and we're actually not pretty sure why this happened, but after removing the multiply labeled questions, many of the 1 million euro questions like disappeared. So removing the multiply labeled questions means those questions, for example, appeared as a 1 million euro questions, but also as a 4,000 euro questions probably. So this notion of difficulty is not like super objectively defined, because some appeared in this quiz show training interactive session on multiple levels. Some other descriptives about the data. This is kind of how the number of words in the questions looked like. So it's some, and with words, we're specifically not referring to tokens here, because token is like specific to the language model you're using, just using ordinary white space tokenization for defining the number of words. So basically the majority is around like 5 to 15-ish. With some more extreme values above 20 or below 5. But overall, pretty short sentences. Adding the number of words in the answers, you're now split up by either the wrong answers or the right answers. And we see that there's actually not a really statistic. And we also tested this with a formal statistical test. We couldn't identify a difference in length between these wrong and right answers. There shouldn't be an easier heuristic, like always the longest answer is the right one. Good characteristic of the data set, I guess. First research question we posed ourselves is, can we fine-tune traditional LLMs like BERT to solve this task? And we took many German models, specifically 6 German ones, 4 BERT-based models, and 2 Electra models. And what we saw is like kind of the expected behavior, right? So after fine-tuning them on 80% of the data as training data, and testing them on the remaining 20% as test data, we saw that performance decreased with the increasing difficulty level, right? So while the performance was quite decent on the easy questions, something up to 500, it steadily decreased, down until chance, right? Because given four options, if you just would choose one by chance, then you would be right with a 25% probability, which is roughly also what BERT gets at 125K, 500K, and 1 million. Overall,
I think you will need to conclude soon because
I have 2 more slides and then I'm done. Thank you. Electra was slightly better than BERT, but nevertheless, no big differences here. Second research questions, how did generative LLMs do? So ChatGPT in this case, and I would argue a little bit better. Performance is steady over the difficulty levels until it like sharply drops for the 1 million euro question without fine-tuning, right? We're just relying on the knowledge already stored here. So what is interesting for the future? Probably gaining more insight where they fail, not only in terms of difficulty levels, but also using maybe chain of thought, examine whether the ordering of the question answers plays a role. There is definitely potential to make this whole thing multilingual, right? Because the study exists in other countries as well. And one very unfortunate thing to finish with, we talked to several lawyers who told us, okay, web scraping, the whole thing is pretty sure legal and using it for our research. But like the production company was very, very not happy with us publishing the data. So until now, we haven't found a solution to make this publicly available without being probably sued or anything. But I try to continue contacting the production company to maybe make it available one day. But if you're interested, I'm happy to send around the data. I'm just not allowed to publicly make it available on Hugging Face, for example.
All right.
That's it. Here are my slides. QR code also goes to the slides, contact information. If you're interested, happy if you reach out. Thanks a lot.